Our solar system is far more expansive and mysterious than just the sun and the 8 familiar planets we all know. It stretches out into the inky blackness, holding secrets we are only beginning to uncover. Beyond Neptune, far beyond the reach of our familiar planetary neighborhood, lies the Kuiper Belt, a vast, icy frontier. This distant realm is a place of frozen wonders and cosmic mysteries. It's filled with ancient frozen remnants, the leftovers from the very birth of our solar system, a cosmic construction site that never fully cleared away its debris. These small icy bodies, drifting in the cold void, are like time capsules, frozen in time. They're preserving secrets, holding clues from 4.5 billion years ago, offering a glimpse into the solar system's infancy. For years, with limited technology, we thought this region was largely empty, a desolate expanse at the edge of our solar system. But as our technology advanced, powerful telescopes revealed that it's actually teeming with thousands of distant worlds, a bustling metropolis of icy bodies. Out here, so far from our home, the sun is no longer the blazing inferno we know. It's just a bright star, a distant beacon in the darkness, and temperatures plunge hundreds of degrees below freezing, creating an environment hostile to anything we know as life. It's a truly alien landscape. Yet even in this darkness, in this frigid expanse, astronomers noticed something strange, something that defied explanation. They observed the orbits of some of the most distant objects in our solar system. These objects, called extreme trans-Neptunian objects or ETNOs, were behaving in a peculiar way. Their orbital paths weren't random, as one might expect in such a chaotic environment. Instead, several of these icy bodies seemed to be clustered together as if drawn together by some unseen force. Their orbits were strangely aligned, pointing in the same general direction, a cosmic coincidence that seemed statistically improbable. And not only were their orbits aligned, but they were also tilted at similar angles, further suggesting a common influence. It was as if an unseen force, a gravitational hand, was shepherding them, guiding their movements through the outer solar system. This suggested the presence of something massive, something far beyond Neptune's reach, exerting a gravitational pull on these distant objects. The known planets, the familiar giants of our solar system, simply couldn't explain this peculiar alignment. This subtle clue, this gravitational anomaly, hinted at a hidden presence, something lurking in the shadows of our solar system. It suggested the existence of a 9th planet, a massive world lurking in the frozen depths, a world we had never seen. The idea was electrifying, a jolt of excitement through the astronomical community. It sparked a new search, a renewed effort to find a world lost to us, a world that may have been hiding in plain sight for decades. Could our solar system really be hiding a giant unseen planet, a world comparable in size to Neptune or even larger? The mystery was on, the hunt was afoot, and the astronomical world was buzzing with anticipation. Astronomers everywhere were determined to find answers, poring over data, pointing their telescopes towards the distant reaches of our solar system. The hunt for Planet 9 had begun, and the quest to unravel this cosmic mystery was underway. The story of Pluto is a fascinating one, filled with twists, turns, and a redefinition of what it means to be a planet. The search for a 9th planet began with Pluto, but its journey from planetary status to dwarf planet sparked a revolution in our understanding of the solar system. In the early 1900s, astronomers meticulously studied the orbits of Uranus and Neptune. They noticed odd, subtle wobbles in their orbital paths, deviations that couldn't be explained by the known celestial bodies at the time. These anomalies hinted at the gravitational influence of a hidden world, a mysterious celestial body lurking in the distant reaches of our solar system. The task of finding this elusive Planet X fell to Clyde Tombaugh, a young and dedicated astronomer at Lowell Observatory. He spent a year painstakingly comparing photos of the night sky, using a blink comparator to identify any objects that had shifted position against the backdrop of distant stars. It was a tedious and demanding process, requiring immense patience and attention to detail. Finally, in 1930, his persistence paid off. He found a faint moving dot, Pluto, seemingly answering the call for a 9th planet. The world celebrated the discovery of a 9th planet, hailing it as a major triumph for astronomy and a testament to human curiosity. The new planet was named by an 11-year-old girl, Venetia Burney, who suggested the name Pluto after the Roman god of the underworld. But as astronomers learned more about Pluto, it became clear that it was an oddball smaller than our moon, and significantly different from the other planets in our solar system. Its orbit was unlike any other planet, characterized by a highly elliptical and tilted path around the Sun. This unusual orbit sometimes brought it closer to the Sun than Neptune, further distinguishing it from the other planets. It simply didn't fit with the established categories of planets. It was neither a gas giant like Jupiter or Saturn, nor a rocky world like Mars or Earth. As technology improved and telescopes became more powerful, we learned that Pluto had moons, adding another layer of complexity to its story. The discovery of Charon, a moon so large that it's almost half the size of Pluto, revealed that the two form a double planet system orbiting a common center of gravity. But Pluto's small size, unusual composition, and strange orbit continued to raise questions among astronomers. Was it truly a planet, a misfit among giants, or was it something else entirely, a new type of celestial object? The debate simmered for decades, with astronomers on both sides passionately arguing their case. However, the discovery of other similar worlds in the outer solar system, in a region known as the Kuiper Belt, would ultimately force astronomers to reconsider Pluto's status. These new discoveries challenged the traditional definition of a planet and prompted a comprehensive review of planetary classification. Pluto's story therefore became a pivotal moment in astronomy, setting the stage for a new understanding of our solar system and its diverse inhabitants. It was the first tantalizing clue that the outer solar system was far more complex, dynamic, and populated than we had ever imagined. And in a strange twist, it opened the door to the ongoing search for a new, true ninth planet, a hypothetical giant lurking far beyond Pluto's orbit. For centuries, the concept of a planet was far simpler than it is today. A planet was simply a wandering light in the night sky, a celestial body that moved differently from the fixed stars. These wanderers held a special place in ancient cultures, often associated with gods and mythology. With the advent of telescopes, our understanding of the cosmos expanded dramatically. We added Uranus to the list of planets, a discovery that pushed the boundaries of our solar system. And then came Neptune, another giant world revealed through careful observation and mathematical prediction. And finally Pluto joined the ranks, seemingly completing our solar system's planetary family. But as our telescopes grew more powerful, we began to find more and more objects lurking in the outer solar system, challenging our established order. The sheer number of these new discoveries forced the astronomical community to confront a fundamental question: what exactly defines a planet? The definition of planet became a problem, a source of intense debate and discussion. In 2006, the International Astronomical Union, the official body responsible for naming and classifying celestial objects, met to settle the debate once and for all. They established a formal definition, stating that a planet must first and foremost orbit the Sun. Secondly, it must have sufficient mass for its own gravity to pull it into a nearly round shape. And finally, it must have cleared its orbital neighborhood of other objects, becoming the dominant gravitational force in its region. Pluto, sadly, met the first two criteria, orbiting the Sun and being nearly round, but it failed on the third. It shares its orbital space with countless other icy bodies within the Kuiper Belt, a region beyond Neptune teeming with celestial objects. As a result, Pluto was reclassified into a new category, a dwarf planet. The decision was met with considerable controversy. It sparked public outcry, with many feeling a sense of loss for the beloved ninth planet, and ignited a fierce debate among scientists, some of whom disagreed with the new classification. Many argued that the new definition was too restrictive, too vague, and ultimately location-dependent, meaning an object could be a planet in one solar system but not in another. But despite the controversy, the decision stood. Officially, our solar system was now home to just 8 planets. Pluto's demotion, while painful for some, marked a turning point in planetary science. It opened the door to a new era of discovery, pushing us to look beyond our familiar definitions and explore the vast diversity of objects in our solar system and beyond. It forced us to rethink our fundamental understanding of what it truly means to be a planet, challenging our assumptions and inspiring new avenues of research. And perhaps most excitingly, it set the stage for the ongoing search for a new, true ninth planet, a hypothetical world lurking in the distant reaches of our solar system. A planet that could confidently meet all the established criteria, reclaiming the title of ninth planet. The debate about what constitutes a planet continues to this day, but the quest to find Planet 9, if it exists, is now at the very heart of planetary science, driving innovation and exploration. The story of what makes a planet is far from over. It's a story that is still being written, with each new discovery adding another chapter to our understanding of the cosmos. Pluto's reclassification revealed a new class of world's dwarf planets. The discovery of Eris, more massive than Pluto, forced astronomers to reconsider what counts as a planet. If Pluto was a planet, so was Eris, and maybe dozens more. Instead, Pluto, Eris, Makemake, and Haumea became the first members of the Dwarf Planet Club. These worlds are round but haven't cleared their orbits. Ceres, in the asteroid belt, was also promoted to dwarf planet status. The solar system was no longer a tidy family of 9, but a dynamic system with 8 major planets and a growing list of dwarfs. This new understanding reshaped our map of the solar system and changed how we think about planetary formation. The Kuiper Belt and beyond are now seen as rich, unexplored frontiers, and it's in these distant regions that the first clues to Planet 9 emerged. The hunt for Planet 9 began with a statistical oddity in the orbits of extreme trans-Neptunian objects, or ETNOs. These icy bodies far beyond Neptune should have random orbits, but several are strangely clustered. In 2014, astronomers noticed their closest approach to the Sun, or perihelion, was grouped in one part of the sky. It was as if an invisible force was corralling them. The best explanation: a massive, unseen planet tugging at their orbits from afar. Their orbits are also tilted about 30 degrees from the main plane of the solar system. Another unlikely coincidence. The odds of this happening by chance are less than 1%. The evidence is circumstantial, but it's compelling enough to suggest a true 9th planet may be out there. The evidence for Planet 9 caught the attention of astronomers Konstantin Batygin and Mike Brown. Initially skeptical, they ran computer simulations to test if the orbital clustering was just a fluke, but the models only made sense when they added a massive distant planet. Their simulations predicted not just the known clustering but also a second group of objects with bizarre, high-inclination orbits, objects that had already been observed. In 2016, Batygin and Brown published their hypothesis. Planet 9 exists, and its gravity shapes the outer solar system. They hadn't found it, but they'd drawn a treasure map pointing to where it might be. The announcement electrified astronomers and the public alike. The search was on, using the world's most powerful telescopes and supercomputers. Finding Planet 9 is like searching for a faint, slow-moving needle in a cosmic haystack. But with a strong theoretical case and a map to guide them, astronomers worldwide joined the hunt. We haven't seen Planet 9, but simulations paint a vivid picture. It's likely 5 to 10 times Earth's mass, a super-Earth or mini-Neptune common in other star systems but missing from ours. Its orbit is vast and elongated, taking 10 to 20,000 years to circle the Sun. At its closest, it's 200 times farther from the Sun than Earth. At its farthest, over 1,000 times. This distance makes it incredibly faint and hard to spot. On Planet 9, temperatures would hover near minus 225 degrees Celsius. The Sun would be just a bright star in a black sky. It's probably an ice giant, with a rocky core, thick icy mantle, and a dense atmosphere of hydrogen and helium. Astronomers now know what to look for: a faint, slow-moving object in a specific patch of sky. Each new discovery of a distant object helps refine the search. The hunt for Planet 9 is a race against the darkness. The search for Planet 9 pushes technology to its limits. The Subaru telescope in Hawaii has been the primary tool, scanning the sky for years. Many new trans-Neptunian objects have been found, but Planet 9 remains elusive. Soon, the Vera C. Rubin Observatory in Chile will revolutionize the hunt. Its legacy survey of space and time will scan the entire southern sky, perfect for spotting faint, slow-moving objects. If Planet 9 is within reach, the Rubin Observatory could find it within a few years. Space telescopes like the James Webb Space Telescope could then study any candidate in detail, confirming its nature and composition. With new observatories and better simulations, the odds of discovery are better than ever. It's a global effort, with every new discovery adding a piece to the puzzle. The next decade could finally reveal our solar system's missing giant. Why does Planet 9 matter? Its discovery would rewrite our understanding of the solar system. A massive planet on a strange orbit would reveal a chaotic, violent past perhaps flung outward by Jupiter or Saturn in the solar system's youth. It could explain mysteries like the Sun's odd tilt and connect our solar system to the thousands of others we've found. Super-Earths are common elsewhere, but ours seem to lack one, until now. Finding Planet 9 would make our solar system more typical, linking us to the broader galaxy. The search is about curiosity and the drive to understand our place in the universe. Even if we never find it, the hunt has already led to dozens of new discoveries and forced us to rethink how planets form. The quest for Planet 9 is a testament to human curiosity and the power of science. There are still great mysteries in our own backyard, and the next great discovery could be just beyond the edge of the known.